Laplace transform. Okay. Let us see a few problems on Laplace transforms. Okay. Before that, let us look at the definition of the Laplace transforms. Let f of t be a function of t specified for t greater than 0, then the Laplace transform of f of t is denoted by L of f of t. Okay, is defined by L of f of t is equal to f of s is 0 to infinity e to the power of minus st f of t dt. Okay, where we assume at present that the parameter s is real. Okay, later it will be found useful to consider s as complex. This Laplace transform f of t is said to exist if the integral converges for some value of s. Okay, otherwise it does not exist. So let us look at some of the elementary functions. Okay. So Laplace transforms of 1 is 1 by s. Okay, where s is greater than 0. Laplace transform of t is 1 by s square, where s is greater than 0. And Laplace transform of t to the power of n, where n is 0, 1, 2, and so on. So this would be n factorial by s to the power of n plus 1 for s greater than 0. Laplace transform of e to the power of at is 1 by s minus a, where s is greater than 0. Okay. And Laplace transform of sine at is a by s square plus a square. Okay, where s is greater than 0. Laplace transform of cos at is s by s square plus a square, where s is greater than 0. Laplace transform of sine hat would be a by s square minus a square, where s is greater than mod a. And Laplace transform of cos hat is s by s square minus a square, where s is greater than mod of a. Okay. So let us find the Laplace transform of cos 2t. Yeah. So this would be s by s square plus 4. Yeah. And let us find the Laplace transform of e to the power of minus t cos 2t. So we know that Laplace transform of e to the power of at f of t a is equal to f of s minus a. So this would be s plus 1 by s plus 1 whole square plus 4, which is equal to s plus 1 by s squared plus 2s plus 5. Okay. Now, if you have f of t as cos 3t, right? So, so we have a Laplace transform of f of t, which is equal to s by s squared plus 9. Okay. Now let us find the Laplace transform of 4e to the power of 5t plus 6t squared minus 3 sine 4t plus 2 cos 2t. Okay. By linear property, we can solve this. So Laplace transform of e to the power of 5t plus 6 Laplace transform of t square, okay, minus 3 Laplace transform of sine 4t plus 2 Laplace transform of cos 2t, right? So which is equal to, this is 4 multiplied by 1 by s minus 5, and this is 6 into 2 factorial by s cube, okay, and s3. So this would be 4 by s square plus 16, and this is 2 times s by s square plus 4. Yeah. So further simplifying it, this is 4 by s minus 5 plus this is 12. Yeah. By s cube. This is minus 12 by s squared plus 16 plus is 2s by s squared plus 4. Okay. So let us find the Laplace transform of t squared e to the power of 3t. Yeah. So let us first find what is Laplace transform of t squared. So this would be 2 factored by s cube, or it is 2 by s cube. So Laplace transform of a t squared e to the power of 3t would be 2 by s minus 3 whole cube. Okay. Okay. Now let us look at another problem. So Laplace transform of e to the power of minus 2t sine 4t. Yeah. Now, first let us find what is Laplace transform of sine 4t. Okay, which is 4 by s squared plus 16. So Laplace transform of e to the power of 2t sine 4t would be that is 4 by, this is s plus 2 whole square plus 16, which is 4 by s squared plus 4s plus 20. Yeah. Yeah. So let us look at another problem, that is Laplace transform of e to the power of 4t cos h phi t. Yeah. So first let us find what is Laplace transform of cos h phi t. Now this is s by s squared minus 25. Okay, so Laplace transform of e to the power of 4t cos h phi t is equal to s minus 4 by s minus 4 whole square minus 25, or which is equal to s minus 4 by s square minus 8s minus 9. Now there is another alternate method for this also, so let us have a look at that also. So our question is Laplace transform of e to the power of 4t cos h phi t. Yeah, so which can be written as Laplace transform of e to the power of 4t. Okay, and this would be e to the power of phi t plus e to the power of minus phi t divided by 2. Yeah, now this is equal to when you simplify this, so you get half of Laplace transform of e to the power of 90 plus e to the power of minus t. Yeah, now this is half. Laplace transform of e to the power of 90 will be 1 by s minus 9. Laplace transform of e to the power of minus t would be 1 by s plus 1. This would be equal to s minus 4 by s square minus 8s minus 9. Okay. Now let's find the Laplace transform of f of t if f of t is equal to this is cos of t minus 2 pi by 3, where t is greater than 2 pi by 3, and 0 when t is less than 2 pi by 3. Yeah, so let us find this. I'll tell you the alternate method also. So Laplace transform of f of t, yeah, which is integral. Now if you look at this, so this is 0 to 2 pi by 3, so where t is greater than uh, uh, 2 pi by 3, so this would be e to the power of minus st. Now this is 0. Yeah, t is greater than that is 2 pi by, yeah, so this is 0. Yeah, 0 to uh, 0 to 2 pi by 3 is 0. Yeah, into dt plus integral. Now t greater than 2 pi by 3 will be 2 pi by 3 to infinity. Okay, so this is e to the power of minus st. This will be cos t minus 2 pi by 3. Yeah, so this is dt. Fine. Yeah, now this is further can write this 0 to infinity e to the power of minus s u plus 2 pi by 3. This is cos u du. Yeah, so which is equal to e to the power of minus 2 pi by 3 integral 0 to infinity e to the power of minus su cos u du, which is equal to s e to the power of minus 2 pi by 3 by s square plus 1. So this is solving by first method. Let us look into the next method. Yeah. So question stays. So Laplace transforms of cos t, right? So is s by s square plus 1. So it follows that a where a is 2 pi by 3, right? So a Laplace transform of f of t, which is equal to s into e to the power of minus 2 pi s by 3 by s square plus 1.